Hey, it's Mr. Allred. Today we're going to talk about calculating compound interest. And we'll explain it as we go. But compound interest, there's really two different formulas. There is compound, what I like to call periodic, and there is compound continuous. So I'm going to give you the formulas and what they all mean, and then we're going to look at them a little bit and work a couple problems eventually. But the function here for compound periodic is a of t equals p times 1 plus r over n raised to the n times t. So let's kind of talk about what this means. So we're talking about interest. We're talking about we put some money in the bank. So when we put money in the bank, the first thing that we see here is P. And that P stands for principal. And so the principal is the initial amount. That's our starting amount. That's how much we would put in the bank to start with. R is our rate, and that's going to be in decimal form. Let's clean that up a little bit. So basically what I mean there is 5%. We would let our R be 0.05. Okay. We'll jump forward to T. T is years. So we would put money in the bank, P amount. It'd be earning interest at some R percent, and we'd leave it in there for T years. Now something that's going to be common here. Let me slide up a little bit. Is the A of t. This is usually called the future value. Or ending amount. Okay. So we're going to put money in the bank, P amount. It's going to earn interest at R rate for T years, and when it comes out we will have A dollars total. So the only thing I've left out there is N, and this is number of compounds per year. So let's kind of give a little scenario here. If we were to leave our money, or excuse me, if we were earning interest monthly, N would be 12. If we were earning interest weekly, N would be 52. So however many times something shows up. So quarterly would be something like 4. Let's go ahead and write that out. So the idea here is that we may say we're earning 5% interest per year in some scenario, but we know that money is probably not going to stay in there for a full year or an even number of years. It might stay in there 5 months, it might stay in there 10 years and 5 months. And generally, if you've had a bank account or you've had a loan, usually there are monthly payments. Okay, you would either go pay for your loan every month, or if you had a bank account and you were earning interest, you would earn interest every month. So that's where I get down here to monthly, or at least that scenario. So you would get a portion of that 5% every period. Okay, every period. So this is why it's periodic. Whether that period is every month, every week, every quarter is not too uncommon. But instead of getting a lump sum of 5% at the end of the year, they're going to break that 5% up and kind of give it to you in pieces. Now, the reason that's useful is because when you get your first interest check, now you have more money in the bank so that you're going to get interest on that extra money you just got in the next period. And I'll show you an example of that in a moment. But let me go ahead and give you the formula for the continuous, and then we'll kind of discern how these are useful. Okay. So the continuous, A of t equals P times E to the RT, which is R times T. So all these things are the same. P, R, T, A we've had over here. The only thing new here is E. E is a set number. It's kind of like pi. It never terminates. It's one of those irrational numbers that keeps going on and on. It's approximately 2.7182 something. You should find an E button on your calculator. But let's kind of talk about where the continuous comes from. So I've got something here I'm going to pull up. Got this spreadsheet here in Excel, and I've calculated some compound interest. So in these right here, I've started off at the top. Every single thing I've got here, I've put $10,000 in the bank at an interest rate of 4%. Okay, so that's 4% per year. So the first four things I have here are using the periodic formula. This is compounded annually, which means it only does it once per year. Compounded monthly, 12 months in a year, so 12 times per year. Compounded weekly, 52 weeks in a year, so 52. Compounded daily, 365 days in the year. So basically you would see a change in your total bank account every day, okay, if it was compounded daily. So I went through here, and I just wanted to kind of explain why we have these two different formulas and how they work. So over here, the first column is years, which would be T. So at year 0, every single one of these, which is the very first starting amount, is $10,000. Okay, so we've put $10,000 in the bank. Now you can follow each year individually, but I ran this down to 15 years. So down here at the 15th year, if we only calculate interest at the end of the year, that means you get all 5% at once, it gives you a total of $18,009 and about 44 cents. Now if we do compounded monthly, that means you get interest every month. Your bank account changes every month. Okay, and you can see that this number is about $200 higher after 15 years. Compounded weekly, that would mean your bank account would change every week. Okay, so that's about $215 larger than the original, and it's about $15 higher than the monthly. And then we go to daily. So like we said, your bank account would change every day. You see after 15 years, not a big difference, but it is even better. So here's the scenario that we're kind of looking at. You're a bank and you're trying to draw customers in. So you notice that the bank across the street is compounding interest monthly. So you want to outdo them and draw customers to you. So you decide to compound weekly. That means they get more money. Not a significant amount, but it is better. That's better for the customer, and the more business you have is better for you. So not to be outdone, the bank across the street changes theirs to every day. So now the customers go back over there. So it goes back and forth. So we could do this every hour, every minute. This would be a large N. We could do it every second. And we could do it fractions of seconds. But what happens is, as we see the total down here doesn't change as much as we keep going, it kind of dwindles off. And we see what we have over here as compound continuously. And that's the other formula with the E in it. This is the best we could do. Okay, so if we kept making our N higher and higher, this is where we end up. Okay, continuous interest. We'll see some examples of growth and decay, or if you think about in biology, maybe a cell would split every hour. So you would see growth every hour. But maybe if you're talking about radioactivity, some of that is given off all the time, continuous. So we see different applications here. So let's just kind of go back and look at the two formulas that we had, and let's do a quick example. So let's just make our own little example here, and let's just say, if we're going to calculate them by hand, because I want you to be able to put these in the calculator. If you have trouble with the calculator, let me know. But let's say we had $5,000. And we have an interest rate of 6%, which would be 0.06. And we're going to compound quarterly, which would be N equals 4. And we want to know how much money we will have after 6 years. So basically, if we want to write it as a function, we're talking about A of 6 equals 5,000 times 1 plus 0.06 over 4 raised to the 4 times 6. And you can pause this and go back and look at the formula up top. But you pick up a calculator, and you got to be very careful how you put everything in. 1 plus 0.06 divided by 4, raise that to 6 times 4. And I've got one of those wonderful errors, so hold on a second. So put this in your calculator. If you need help, contact me. But you're going to get around $7,147.51. Generally these things I round them off to $1. Okay, so if you can't get that in your calculator, we need to talk. One thing that's very important, is going to be very helpful up here, is making sure you put parentheses around this part. So let's do the same thing. $5,000, 6%, but we'll do it continuous for 6 years. So once again, we're plugging in 6. So we've got 5,000 times E raised to the rate, RT. So we're going to put that in our calculator and look for your E button. Uh-oh, something's happened there. Hold on 1 second while we find our E. So after all is said and done, you mash all the buttons. Take your time, make sure you do it. Pick up your calculator, make sure you're getting the right thing. $7,166.65. So make sure you understand the difference in what we did here. The first example was a periodic, which was quarterly. The second example was continuous. The only thing that can mess you up here really is using the wrong formula, using the wrong N if it is periodic, and also typing in the calculator wrong is a big issue. But just identifying the parts should not be too much of an issue. You'll get a chance to try some of those. All right. Contact me if you have any trouble getting this in the calculator or understanding the formula. Once we get that straight, usually it's not too big of too many problems. Thank you.